We're on video 4. We are almost there, and I am so proud of you guys. Let's get started right away. Systems of equations. Anytime we see the word systems, as far as we are concerned, we are thinking about two equations, okay, or two functions, two rules. We have to somehow solve them. A linear equation, we're just going to talk about what it looks like in standard form, and it's y equals mx plus b. It has a highest variable of 1, and it is going to be a line. A quadratic equation in standard form is y equal to ax squared plus bx plus c, and this actually gives us a parabola, which is a u-shape. In math, we call that a parabola. So let's describe some of these basic functions. It's not all the functions we know, but it's the ones that we see most often. A linear function takes the shape of a line, and basically, let's draw what that looks like. Looks like a line, okay? Absolute value function, if you remember, just like the v here in absolute value, we get a v-shaped graph. So a v-shaped graph. Quadratic function, going to make a U shape, and before, above, over here you see we called it a parabola, okay, but it is a U shape. And just keep in mind the V and the U over here, and even the line can be any other direction. For example, this U can also look like this. They're both U shapes, okay? A piecewise function has any combination of these, okay? So two or more functions combined. So it's like when we try to graph multiple functions on the same graph. And just as an example, let's say maybe you start off with a line. So you start off with a line, and then suddenly it turns into like a U shape. So we call this a piecewise function, okay? It's like a combination of these. So let's get practicing. First problem over here. On the accompanying grid, draw the graph of the line whose slope is 2/3 and whose y-intercept is -2. So I know I have a slope of 2/3 and a y-intercept of -2. Well, before I can even start graphing, I actually need to make my x and y axes. This is a 20 by 20 grid, so I want to split it up right in the middle at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then going down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's draw our arrows for our axes. So first things first, I know I have a y-intercept of -2. A y-intercept of -2, that's right here. And then our slope is 2/3, which tells me that I should be going up 2, and then to the right 3, since they're both positive. Up 2, to the right 3, up 2, to the right 3, up 2, to the right 3. And look, I can't go to the right, I can go up 2, but I can't go to the right 3 anymore, so we need to do the complete opposite. The complete opposite of up 2 is going to be down 2, and to the left 3. So, down 2 to the left 3, down 2 to the left 3, down 2 to the left 3. And let's connect this with a line. So, let's make sure our line has arrows on both ends. And last but not least, please remember to, well, this one doesn't have an equation, so it's okay. But if we wanted to label this, this would be y equals 2/3, because that is my slope, that is my m, x minus 2. Okay, the next one on the set of axes below, graph f of x equals to the absolute value of x minus 3 plus 2. Here's where you pull out your handy dandy calculator. Let's go to y equals. If I want to get the absolute value symbols, we press math, go over to number, absolute value, x minus 3, and then plus 2. Let's just look at the graph. I need to translate this onto our paper, so to do that, I'm going to look at my table of values, and let's start by looking for our turning point. I see that our turning point is 3, 2 because the numbers on top start repeating. I'm going to copy this down. X, Y. I'm going to put 3, 2 in the middle. And then I have 2 and 1 and 4 and 5. Okay, so let's see. It was 3, 2, 2, 3. So this was a 3. This was a 4. This was a 3. This was a 4. And let's plot some of these points. So 1, 4 over 1 up 4. 2, 3. 3, 2. 4, 3. 5, 4. Okay, let's connect these with a line. Make sure your line goes through all the points. If you're unsure, you should plot the rest of these points. Okay, looks pretty good. Draw my arrows since this does go on forever. And let's label our graph. So this was f of x equals to the absolute value of x minus 3 plus 2. Okay, we're done with the first page. Second page, where do we find the solution to a system of equations? At the intersections. Okay, a solution to the system of equations is going to be at the intersections. We talk about 3 different ways to solve solutions. The first one is by using substitution. We can only use that when one of our variables is solved for. So over here, you got c equals to 4d minus 6. So you have c equals, so it's been solved for. Okay? So I'm just going to write it up here, rewrite the equation. C plus 3d, and I'm purposely doing it in a different color because I want to show you what I'm doing, equals to 8. Well, if c is equal to 4d minus 6, can't I replace c with 4d minus 6? The answer is yes, I can. Okay, because they're exactly the same thing. If 2 things are the same, you can just replace them with each other. Okay, the next thing you're going to do is get rid of these parentheses. Since there's nothing to distribute, you can just get rid of them right away. Alright, I need to turn that off. I turned it off, so now let's take a look. I got rid of the thing by distributing, and now let's combine like terms. Combining like terms mean anything with the same variable and exponent I can combine. I got a positive 4 and a positive 3. Just so I can show you guys how we're combining, we're adding those terms together, okay? So 4 plus 3 is 7. I now have 7d minus 6 is equal to 8. If you know the next step to solving a any equation, you're going to add 6 to both sides. If you have room, please continue down here. Otherwise, I'm going to move up here. So I get 7d is equal to 8 plus 6 is 14. Divide by 7 on both sides. D is equal to 2. Alright, so D is equal to 2, meaning it's not answer choice 1 and it's not answer choice 4. To find out what C is, I'm going to plug it back into this equation. C equals to 4D minus 6. Well, what is D? D is 2. So C is equal to 4 times 2 minus 6. Let me plug this into our calculator. 4 times 2 minus 6. 2. So C is also equal to 2. Which means it must be answer choice 3. Alright, the second way. Oh, this is kind of messy. There you go. Alright, moving this all up. The second way to solve systems of equations is by elimination. Elimination happens when neither of the equations have been solved for, and what you want to do is just line up the 2 equations. So I got x minus 2y equals to 1. And your other equation is x plus 4y equals to 7. When you want to use elimination, what you need are opposite coefficients. So what we're going to do is make sure they're opposite coefficients. I have 1x and 1x. These are not opposite. So what I want to do is actually just multiply the top equation by my coefficient of the bottom and multiply the bottom equation by the coefficient of my top, but I need to make one of them negative. I'll make the bottom one negative. Okay? So if I multiply the top by positive 1, I just get 1x minus 2y equals to 1. And then I'm going to multiply the bottom equation by negative 1, so I end up getting negative 1x minus 4y equals to negative 7. Alright, what I can do next is to eliminate. 1x and negative 1x cancel out. Let's add these together. So I have negative 2 plus negative 4 gives us negative 6y. So negative 6y, 1 plus negative 7, 1 plus negative 7 gives us negative 6. Let's divide by negative 6 on both sides. Y is equal to 1. And let's see. Oh, they're asking us for the y coordinate, so I don't even have to solve for the x coordinate. Y is equal to 1. We're good to go. Method 3 is by graphing. So when we have two linear equations, we look for their intersections. Let's at least figure out where these points are. So 0, 4. This is our y-intercept. 2, 4. Oh, let me color code these. This is fun. Okay. So 2, 4, go across 2, go up 4. That don't look like an intersection. 4, 2. Oh, hey, you know what? That kind of looks like an intersection, but let's just check, and 8, 0. And this is the x-intercept. We're looking for the intersection of our two graphs. Of our two lines, and that's going to be answer choice 3 at the intersection, okay? All right, let's move on. Quadratic linear systems. So this one is almost the same thing, okay? Method 1, we're going to use substitution, and that's when you have both equations solved for. You see how this says y equals and this says y equals? So I'm going to copy down this first equation, y equals to x plus 3. And hey, if y is equal to x squared minus x, then I can replace this y with x squared minus x. So instead of writing y, I'm going to write x squared minus x equals to x plus 3. Now we have a simple, not simple, but it's going to be a quadratic equation. To solve for it, I need to get it equal to 0. We did quadratic formula in the last video. If you don't remember how to do that, go back to the last video. I'm going to first subtract x from both sides. And then I will get x squared. Oh, this is annoying. Okay. X squared minus 2x equals to positive 3. And I need to take away the 3. 3. Minus 3. Just be mindful that you can't combine these because there's an x here and there is no x here. So I end up getting x squared minus 2x minus 3 equals to 0. And now I can actually begin to solve by identifying our a, b, and c value. A is 1, b is negative 2, and c is negative 3. Okay, I'm gonna let's solve this by factoring. Let's review how to do that. So to solve by factoring, you're gonna make an a times c table, and needs to add up to b. So a times c in this case is negative 3, and our b value is negative 2. Negative 3, I can have 1 and negative 3, and I can also have negative 1 and positive 3. The one that will help me add up to negative 2 is going to be 1 and negative 3. So what you're going to do is, using this equation, replace the middle term. So now I will have, let me just see if I can copy this to make it easier. No, not this. There you go. So instead of this 2x, I'm going to put in the two new things I found. Plus 1x minus 3x minus 3 equals to 0. All right, let's draw our parentheses around the first two terms and parentheses around the last two terms. Around the first two terms, I can factor out an x, and I will be left with x minus 1. Around the last two terms, I can factor out a negative 3, and I will be left with x minus 1. Did I mess up somewhere? I feel like I messed up somewhere. Alright, I have to have messed up somewhere because this ends up becoming x plus 1. Here's where I messed up. I'm sorry. This is plus 1. This is a horrible video. I'm the worst. I messed up. Oh my gosh, what is going on? Okay, I'm sorry. Okay, so I get x plus 1. And then you see how that was an easy check for me? I knew I was wrong because inside my parentheses were not the same. So now that they're the same, that becomes one of my factors, x plus 1. Your other factor is everything outside of the parentheses, x minus 3. Equals to 0. So now to solve for both sides, let's split it up into two equations. I got x plus 1 equals to 0. And also x minus 3 equals to 0. I will eventually move this all up so we have room. Minus 1, minus 1. I get x equals to negative 1. Plus 3, plus 3. I get x equals to 3. This is the longest problem ever. Okay, x equals to 3 or x equals to negative 1. Well, actually, I need an ordered pair, right? These are x and y coordinates. None of these, this one doesn't have an x value of negative 1 or 3. This one doesn't have an x value of 1 or negative 3. So, I know it's long, but we're not done yet. What we need to do next is plug in these equations. And I'm sorry, I'm trying to make this smaller so we have room to do work. This is awesome because if you're not watching it, you have no idea what's going on if you're not listening. Okay, so I eliminated those first two answer choices, and now what I need to do is let's solve for y. I'm going to use this equation because it looks a lot easier. Y equals to x plus 3, and I'll do it up here. So, y equals to x plus 3. You can do it wherever you have room. We said 3 is equal to, x is equal to 3. So y is equal to 3 plus 3, which means y is equal to 6. So I got 3 and 6. Awesome! Oh my gosh, that took forever. Okay, this next one's going to be easier, I promise. Solve the following systems of equations graphically on the set of axes below and state the coordinates of the points in the solution set. So I need to graph both of these. Let's graph the first one. Where's my calculator? Y equals to x squared. Well, I should clear this. X squared minus 6x plus 5. Let's take a look at our table. The turning point is at 3, negative 4, so I'm going to copy down those values. I got x, y. I said 3, negative 4, right? And then let's see what values were on top. So 2, negative 3. I hate this. I hate this. I hate this. I'm so sorry, guys. 2. I can't even remember. 4, 5. Sorry. 2, negative 3, 1, 0. Negative 3, 1, 0, which means on the other side was the same. Negative 3, 0. Okay, sorry. Let's get to this. 1, 0, so that means go over 1, but don't go anywhere up and down. 2, negative 3, 3, negative 4, 4, negative 3, 5, 0, and since it's a parabola, let's actually graph all the other points. I got 0, 5, 0, 1, 2, 3, 4, 5. What else? Oh, I actually can't do that one because it goes off the graph. So let's just do this last one, and let's connect by forming a parabola. This was a quadratic equation, so we should be getting a parabola. Oh my gosh, hopefully on your paper it's prettier. Okay, that's good. That's our parabola. Let's label it. I don't know what I'm doing. Y equals to x squared minus 6x plus 5. Okay, so next I need to graph this second equation. This looks like it's a line, but it's not in the right form. 2x plus y equals to 5. To get it into graphing form, I need to get y by itself. To do that, I'm going to subtract 2x from both sides. Minus 2x minus 2x. Cancels out. Y equals to negative 2x plus 5. And now it's in the form y equals to mx plus b. And this is something we talked about in our class before. The B stands for begin. This is our starting point. Begin. And the M stands for move. Move. It's how we move, okay? So, begin at positive 5. 1, 2, 3, 4, 5. This is how I wish my parabola was better. And move, let's turn this into a fraction, down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. I need to do a different color. Down 2 to the right 1. 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 I can't do down 2 to the right 1 anymore. So we're going to do up 2 to the left 1. Up 2 to the left 1. And let's connect. Arrows and arrows, 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 and I'm going to label it with the original equation. So 2x plus y equals to 5. All good. It says state the coordinates of the points in the solution set. So one of the coordinates is over here where they intersect. I know it doesn't really look like it because of my bad parabola, but it's okay. And here's the other one. This point was 0, 5. So 0, 5. And the other point was 1, 2, 3, 4. 4, negative 3. So those are the two coordinates of our solution. Okay, let's keep going. Which graph can be used to find the solution of the systems of equations? Alright, this one's really easy because all you have to do is go in your calculator. And let's plug in the first one. Right, we said the system of solutions is where they intersect. So, 2x plus 6 and x squared plus 4x plus 3. Graph. Let's compare. So, I noticed that, first of all, my U shape is upright, like a smile. So, let's eliminate these two. Oh, and here's where the struggle comes in. These kind of look the same, right? Let's see if I can compare them both at the same time. Okay, so what I notice is that my blue line has an x-intercept of 3. Okay, this one has an x-intercept of not 3, and this one has an x-intercept of 3. So this must be the correct answer. Okay, almost there. Other systems. We always want to solve other systems graphically. So they give us two graphs here. Based on the solution, based on the graph, the solutions to the equation f of x equals g of x. I know it's the points where they're intersecting. So right away, it's not the x-intercept and it's not the y-intercept, okay? Are we always looking for the x value or the y value? That is a big question. When we are solving systems to solutions to systems, we are always looking at the x values. Done. Oh my gosh. All right, last problem, I think. Nope. On the set of axes below, graph this. Okay, so g of x equals to 1/2 x plus 1. Well, this is easy because we begin at 1 and we move at 1/2. Okay, so begin at 1. Move at 1/2 means up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, and since we can't do that anymore, down 1 to the left 2, 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 down 1 to the left 2. Awesome. Arrows. What am I forgetting to do? What am I forgetting to do? What am I forgetting to do other than the arrows? I am forgetting to label. Okay, so let's label it really quick. I didn't even do arrows. Okay. Let's label this. This is g of x equals to 1/2 x plus 1. Okay, so this is a piecewise function because we got two different functions here. I'm going to do this first one in red. It says f of x equals to 2x plus 1 wherein x is less than or equal to -1. So what that means for you is that when you make your table, we need -1 and I want numbers that are less than or equal to -1. So I got -2, -3, -4, and so on. It goes on forever. Okay? So let's get those values from our calculator. Go to y equals, clear this, y equals to 2x plus 1. And let's get those values, -1, -2. So I got at -1 is -1. This was -3. This was -5. And this was -7. All right, let's graph. So at -1 is, and oh, also look at this symbol right here. It's the or equal to, which tells me that it should be a closed circle. Okay, it has the or equal to. I shouldn't do that. What I should do is this, or equal to. Okay, so 1, -1, sorry, -1, -1, -2, -3, -3, -5, -4, -7. Okay, and it keeps on going forever in the down direction, but not in the up direction. We have to stop at -1. So let's connect this with a line. All right, I give up. Nope, arrow's going the wrong way. So I don't want an arrow in the start direction. Come on. Does that make sense? Okay. Okay, let's do the other one, and I'll do this one in purple, my favorite color. 2 minus x squared. When x is greater than or equal to just greater than. So I got -1. I need numbers greater than -1. 0, 1, 2, so on and so forth. Let's do this. 2 minus x squared. Graph. No, table. -1, I get 1. I should have looked at the other values, but I didn't. 0 is 2. 1 was 1. And 2 was -2. Let's write down another one because I can. 3 was -7. Okay. So, at -1, we had 1, but it was an open circle. Make sure it's very obvious that it's open because we don't have the or equal to. All right, at 0 we had 2. At 1 we had 1. At 2 we had -2. And at 3 we had -7. Okay, let's connect. Parabola, think U-shaped, U-shaped, U-shaped. It's an upside down U. And arrow. Okay? So now they're asking how many values of x satisfy the equation where they're equal to each other. Explain your answer using evidence from the graphs. Alright, so they're not asking us for the solutions. They're just asking how many. How many? Remember that where they're equal, this, what we're looking for, it's called we're looking for the intersection. So how many intersections are there? Just one, right? We only have this one intersection right here that I've marked in yellow. So if there's only one intersection, there is one value of x that satisfies the equation f of x equals to g of x because there is only one intersection. If you need to pause the video right now so you can copy this, go ahead. Otherwise, let's keep going. Oh, Just kidding. You thought I was going to do these practice problems with you. Well, I'm going to leave a special note for those of you who are not listening and just watching. You need to do these practice problems on your own. If you were watching and listening to the entire video, you should have no problem doing this. If you were not listening to the video and just watching it on mute, this might be difficult. Go back and listen to the video. All right. That's all. Bye. Good luck.